Please welcome Hanan Elsayed.
Hi everyone. Every year, millions of cancer patients receive chemotherapy all over the world. The hardest part in chemotherapy is the side effects. The side effects happen because the chemotherapy is not only targeting cancer cells, but also normal cells. That's why searching for new anti-cancer drugs from natural sources is really important. One of the natural products that they found has significant anti-cancer effect was found in our kitchens, turmeric. It was approved that turmeric has an active anti-cancer molecule called curcumin. That's why researchers start to design new anti-cancer drugs, similar in structure to turmeric or to curcumin molecule, and call these compounds curcumin analogs. To evaluate the safety and efficacy of the newly designed anti-cancer drugs, we need a sensitive and selective analytical tool to detect these drugs in the sample in an efficient way. In my research, we were able to establish a method to detect these new drugs in a sample using mass spectrometry. Mass spectrometry is one of the most powerful analytical techniques in research now. So how mass spec can see or detect the anti-cancer drugs in a sample? So if you have a sample, blood sample from a patient, when we inject the sample into the mass spec, the sample, through chemical and physical process inside the machine, the drug in the sample will break down into pieces. When we collect all these pieces together like a puzzle, we can get the structure of the drug, and we can detect this drug in the sample. This is what we call mass spec fingerprint, because it's very characteristic for each drug, like our fingerprints. In my work, we were able to establish the mass spec fingerprints of all tested and newly designed anti-cancer curcumin analogs. These fingerprints not only to detect these drugs in the samples, but also we can use it to know the concentration of the drug in the sample. Not only that, actually we were able for the first time to establish a general mass spec fingerprint for all tested compounds, which means in the future, if a research group design any molecule similar to our molecules, they can use our data and they can detect their drugs in their samples. And this is how we can detect and see the drugs in the patient samples. Thank you.